Okay, sanibona Mageba lo usesibuyile guys. I want to thank you for keep on supporting me, supporting the channel. I really appreciate it a lot. Ngitshele nabanye ukuthi hayi uMageba ukhona uyasebenza kakhulu. So today we're gonna continue with theorem wethu from theorem 4. Our last video was from theorem 3. I hope you still understand, because theorem 1, theorem 2, theorem 3 going to theorem 4, everything is connected. So you must make sure you do understand, because everything is literally connected. I'm going to prove this theorem, but you don't need to know how to prove this theorem. But I'm just going to show you how do we prove this theorem. Theorem 4, it's in an arc or a chord of a circle subtend equal angles at the circumference. What circumference? This circumference here, these angles here. We say an angle in the same segment of a circle are equal. These angles, these are in the same segment. This is segment, meaning these angles are on the same segment, so are equal. Another thing, you must see the shape of this thing. It's like a butterfly shape. This one. All these points are at the circumference. Also make sure you understand it one. Just gonna prove this theorem on how do we say this angle here it's equal to this angle, or this angle here it's equal to this angle. By doing that, you must also first state the given. The given part is that O is a center, which is O here is a center, and then another given part is that A, B, C, and D are points on the circumference. What is required to prove? What is required to prove? We are proving that angle A, which is this one, is equal to angle B. This one is equal to this, and C is equal to D. C is equal to D. Now let's prove. We will prove this one for now by joining OA, O, and then OB. By joining these two like this. I hope now you see the shape of this one from theorem number 2. This shape. What does this shape saying? But let's start saying join. We joined ubani, OA, and ubani, OB. Oh, sorry about that one. Sorry. And then now ubani, OB, which is this angle. Remember, we are talking about this angle. AOB is equal to upindale. This is 2 times equal to this one. This is 2 times this one, which is angle. Oh no, this one. I hope you remember now. This one and this one. You still remember the shape of theorem number 2? There are 3 times. There's this one, that I'm talking about now, this one, and also this one where there is this shape. I hope you still remember this one, where here is a center, where this one is 2 times this one. That's what we are going to use here, which is C. This is the one that we are going to use, not this one. We're not going to use this one, but it's also, this one is 2 times this one, but we are going to use this one from here. So it's 2 times 1. You see, our reason is that angle at the center is equal to 2 times an angle at a circumference. And also the same angle to this one. Now AOB is equal to 2 times 1 with D, which is the same reason. Please guys, write the reason, don't do it like this. Still the same reason from here to here, also the reason from here to here. The 2 angle at the center twice the angle at the circumference. From here, this one is 2 times this angle. Also this same angle, this one is 2 times this angle. So if this thing, if OOP is equal to 2C and OOP is still twice 2D, meaning 2C is equal to 2D. Reason they are both equals to A O B. Then we just divide by 2. We divide by 2. What is our answer? You see, not D. Then we're done. This one is equal to this one. By proving A no B, we're joining from this side now. Still gonna give you the same answer. I hope you understand that part. I hope you do. Then coming to this one now, the converse of it. The converse of it, what the converse saying? If a line of a segment joining 2 points obtains equal angles of 2 other points on the same side on the line segment, then these 4 points are cyclic. Now, if this and this one, guys, please, they're gonna ask you prove whatever 4 point, but it's a cyclic quad. Proving a cyclic quad. This is one of the things that you need to prove. You need to prove that this angle is equal to this angle. If this angle is equal to this angle, you're gonna prove it. And based on a question, not proving a theorem, but on a question that's saying prove it's a cyclic quad. If you prove this such angles that are equal, therefore this thing, which is these 4 points, this is a cyclic quad, where this thing here and then this thing here, then it's forming a cyclic quad. This is what we are going to prove when you're proving a cyclic quad. They say prove that whatever question is a cyclic quad. This, you must prove these angles are equal, or these angles are equal, and therefore then it's a cyclic quad. Okay guys, now we're gonna do the correlation on theorem 4. What does theorem 4 say? This one, the correlation of it, when we have these equal chords, you're gonna see these types of question. You need to know how to answer this type of question. The first part of it, it's saying equal chords subtends equal angles at the circumference. Now they are saying this chord is equal to this chord. Let's go to the first chord, which is this chord. You place your chord like this, the circumference like this. You go top, you go top, you go top, you go top, they meet here. You come this side, you go top, you go top, you go top, they meet here. Where they meet, you see low meter now, and also from here go top, they meet here. So this one is equal to this one. What is the reason? Equal chord subtend equal angles at the circumference. Now, circumference, that's where they subtend each other. Equal chords subtend equal angles at this circumference. Now, coming to this one, equal chords subtend equal angles at the center. At the center. This is the very important. This one is subtended at the circumference. This one subtended what? At the center. This is the chord. They are saying this chord is equal to this chord. Now, if they are saying those chords are equal, place your finger here, place your finger here, go, they meet here. Come to the other one, place your fingers here, go, they meet here. So this one is equal to this one because equal chords subtend equal. Guys, it's not vertical. It's not vertical because now if you're saying it's vertical, if you go here, then from here, this thing is not going exactly like this. It's not vertical angles. Vertical angle is supposed to be like this. Then you're gonna say it's vertical. This one is not vertical angles. But tell a chord layer chord. So you go like this, and you also go like this, and then they are equal because equal chords subtend equal angles at the center. At the center. What is the other one? The third one saying now they're saying equal chord of the circles, two circles, subtend equal angles at the circumference. Again, this is equal, and also this one is equal. Now, the same process. You place your finger here. You go top, you go top, you go top. Also from this side, place your fingers here. Go top, go top, go top, go top. Here. So this one now it's equal to this one. Reason: equal chord of equal circle. Guys, circles S here because there are two circles here. So equal chord of equal circles subtend equal angles at what? At the circumference. Equal chord of equal circles subtend equal angles at the circumference. These reasons are more or less the same, but they are not the same. They are very important things here. Equal chords subtend equal angles at the circumference. This circle is 1. Equal chords subtend equal angles at the center. Equal chord of equal circles. This thing is very important. If you have two circles, subtend equal angles what? At the circumference. I hope you understand it one. Thank you so much. Okay, now we are going to go to do some examples on the theorem that we just did. Now just gonna dwell on doing the example, the application of it. Now they're saying here they gave us this thing, and then first thing, guys, the shape is very important when you are going to see this theorem, because these 4 points here must be at the circumference. These 4 points here must be at the circumference, and also the shape of it, this butterfly shape, is also very important. This shape must form. If we have this shape, and then this one now is gonna be equal to this one, where is x is equal to 20, y angle at semi segment. Angle at the semi segment. At the same segment. then y, because now this one is the same as this one, then y is equal to 15y angle at same, not same segment. The shape is very important, this butterfly shape. Then this one is equal to this one, and this one now is equal to this one. Shape is very important. And then now coming to this one, looking for x and y, shape also here is very, very important. There is the shape. First, make sure all the points they touch at the circumference. The shape, the points they touch at the circumference, also having this butterfly shape. But circumference, and also do have this shape, then this is equal to this. So y is equal to 10 y angle at the same segment. And after that, you can look at this one where it's x. The shape is also very important. The shape is very important. This one now, it's also the same as this one. I hope you see the shape from here. This one here, where x it also is equal to 10, same reason, angle at the same segment. I hope you do get it. I hope you very do get it, because the shape is very important in this one, and also making sure all these points are at the circumference, because this shape you also do get it when this thing is a center. So it's not the same. All these points here must be at the circumference before this thing works. All them must be at the center. Thank you so much. Now we're gonna dwell on doing the example now, explaining the correlation on theorems, the one of chords that are equal. I'm gonna explain that one, seeing some practical example on it. I hope you still remember, if we have this equal chord, they're telling us this chord is equal to this chord. Into yenzayo, you just place your chord like this here, then you move, you go this side. So now this, you know this angle, you go to the other chord from here, you go like this, it's meet here. So now this is equal to this. I hope you see it. Now x is equal to 15. Then now y, the reason, equal chord subtend equal angles where at the circumference, at the circumference. They are subtending when at the circumference. These points are at the circumference. These are equal chord from here going top, from here going top. Where is this top? This top is at a circumference. So equal chord subtend equal angles at where? At the circumference. I hope you get this one. I hope you do, guys. Then coming to this one now, they want this x. Two equal circles. 2 equal circles. O is a center. Now when O is a center, guys, O is a center. From theorem number 1, if O is a center, you must make sure there are some radius there. If O is a center, then OB is equal to ubani? OA. Why? Amaradi. From theorem number 1. From theorem number 1. O is a center. We just took that from there. And then if O is a center, again, theorem number 2, there is a shape that we must see from theorem number 2 if O is a center. Now, I hope you're going to see this shape. This one going to, because this thing must be at the circumference for this one to happen. Now you see that this 2 times this is equal to this one. You repeat E1 uphinda ka-2 to be equals to this 120. Angle at the center is equal to twice the angle at the circumference. I hope you do understand that one. So E1 umphinda kabili uzalingane nobani? No A O B, which is this one, AOB. Thini reason yakhona? Angle at center is equal to 2 times the angle at the circumference. Yeah? I hope you understand that one. And now we're gonna go to the chords. They are saying this chord here is equal to this chord here. Methane. Just go to here, the ends of your chord. Then you go here, you hamba. La ifika igcine khona here. Ifika igcine la. You go to the other chord. Place it emakhoneni akhona. Go here. Then ifika igcine la. So now what is this saying? It's saying x wethu is equal to E1. Y equal chord of equal, E of 2 equal circles, subtend equal angles, where it's circumference here and also this one, it's circumference. But let's first find E1 before going to this one. E1 we're going to find it because it's 2. E1 is equal to this. But what is this? Is 120. When is 120? We divide by 2. Then E1 is equal to 120 divided by 2, 60. Then it's going to find 60. And then from there, E1 uzolingana nobani? No x. Y reason equal chords of equal, because we have 2 circles, guys, of equal circles, subtend equal angles, where at the circumference. It's very important. A certain where at the circumference.
because at some point they can subtend at the center, so must be specific where do they subtend these angles. And also something that is very important, equal circles. Circles, they are equal, there are circles there which are two circles, so must be specific about that one. Then if you get that one, I don't think you're gonna have a problem, guys. I don't think you're gonna have a problem. And again, you must practice these things. Intro and geometry need you to practice it. Just practice, guys. Thank you so much. I hope you enjoyed our lesson. See you next time. Makebalo.